Hi Bart, this is your recap video for Saturday. We did two main topics, volumes of different shapes, those ones we can see here, and indices or powers is another name for it. First thing we asked you was why is cubing called cubing, just like squaring is called squaring, and it's because of course you get a cube. So here's my another amateurish go at drawing a cube. So if we had a cube there where the sides were 7, here we go, 7, 7 and 7, and they're all meters, what would the volume of the cube be? So just pause the video for a second and calculate what that would be. Okay, so you should have got 7 times 7 times 7, because that's why it's called 7 cubed. So that gives 343 meters cubed. So then I asked you about the unit of volume is meters cubed for volume, and why was that? So can you remember why? Again, pause the video and have a think about why that was. Okay, the reason is just like squaring and finding the area of a rectangle or a square or any shape. The definition of area is how many squares can we get in the shape. The definition of volume is how many cubes can we get in the shape. So the cube size is 1 meter by 1 meter by 1 meter. So it's a smaller cube where the sides are all a meter. So that's another normalised shape. It's all intended of 1. And that means in this cube up here, we can get 343 of those cubes. And as I said yesterday, it's a bit like just about the size of a washing machine. A bit rough, but that's going to give you a sense of how big a meter cube is. So we can fit 343 washing machines into this cube, believe it or not. Okay, then we moved on to what if the numbers were different. So if we had, say, 5 meters, 3 meters, and 10 meters, what shape would that give? That's called a cuboid. And to find the volume of that, we'll just do it the same way. So we find the area of the side, it's one of the sides, so that's 15, and then times that area by the depth. So the area through the depth takes up space. Imagine that area moving backwards, it takes up space or volume. So the volume is going to be 15 times 10, which is 150. So that would be 150 meters cubed, meaning we can get 150 of the cubed in there. And then we looked at a cylinder. So for a cylinder, again, we're going to find the area of the side. So we're going to find the area of the circle. So the formula for the area of a circle, as we looked at last week, is pi r squared. Again, strange number because we can't get square peg in a round hole. We can't get a round number of squares in a hole, in a circle. So that's why it's 3.14 squares. So it's, remember, area is to do with squares. So a way to remember that this is the formula is it has for area, it has a square in it, and that's what the definition of area is, how many squares I can get in. So for a circle, it's going to be pi r squared. In this case, if we choose the radius to be, let's say, 5 meters, and the height to be 10, then we're going to get a volume of the area multiplied by that height. So if you imagine that circle going through the depth or height of 10 meters, that's going to give us, in general, it's going to give us pi r squared times by the height, which in this case will be pi multiply the radius squared, which is 5 squared, which is 25, times by the height, which is 10. So times them all together, and we're going to get 250 pi meters cubed, and multiplying that by 3.14 as a decimal, with 785 meters cubed. Now there are actually some decimal points there. Remember I showed you on the calculator. It's actually 785.4, but I was just using 3.14. It gives me 785. So you see, it's not a whole number. 785.4. It's not a whole number of cubes that I can get in. It won't be because we can't put square pegs in round holes. But then I had a brief chat about how engines work, and the reason I did that was to show you that we do use this sort of stuff in everyday life, and even your car that you drove home in, did you find out what the engine size was? Has got cylinders in it, and the engine is measured in the size of those cylinders. So they use cc. So you might have heard, like I said, you might have heard that with scooters or mopeds. They might have like 125 cc. The cc, what does that stand for? Do you remember? Yeah, cubic centimeters or centimeters cubed. So it's just another way of saying that. Okay. I showed you my car's one, and the cc for it was 1984. But if you look at the documentation somewhere else, it would say 2 litres. And the reason for that is it just gets rounded up. Because I can't put square pegs in round holes, I'm probably not going to get a nice round number like 2000 cc. Turns out we're going to get a bit close. I know, sort of close to that, but not close enough. But for ease of communication, people just round it up, so people say, oh, it's a 2 litre engine. So 1000 cc, 1000 centimetres cubed, is a litre. So you can get, in a litre bottle of water, you can get 1000 centimetre cubes. Okay, so that was volumes. So then what we did was we looked at powers, or indices as they're called, and we talked about how we actually know everything we need to know about those already because I've already done the rules with you, and those rules are the usual rules of math that we started off on day one. That's the beauty of the system that I use, that you just, once you learn the rules, you get to apply them everywhere. And maths itself has got a very limited number of rules and a pattern throughout, so we're just going to use that same pattern. So looking at the next page, I want you to pause the video and just have a go at these questions and take as much time as you need, and I'll go through them when you restart the video. Okay, so the first question, 7 squared times 7 cubed, that's going to be 7 to the 5. Why? Because multiplication is addition. So instead of writing out 7 times 7 times 7 times 7 times 7, what we do instead is be a bit cleverer than that and think, well, the total number is just going to be those two added together. So I'll just add them together. And of course it follows the rule from the very first thing we learned, multiplication is addition. Second one, division is just subtraction, so it's going to be 7 cubed. Same thing, division, a subtraction, second rule of maths. And also the 7's are going to cancel out, so you've got 4 on top, 1 on the bottom, 1 is going to cancel, so that leaves us with 3. So a quicker way of doing that, just subtract. 7 to the 0 is 1. Now that might seem strange, it's like the second abstract concept you come across in maths. And it's down to what must have happened is that we had 7 to the power something, like 7 squared, and it got divided by itself, because that's the only way to get 1. But we've also learned that division is subtraction, so 2 take away 2 is nothing. So powers wise, it could be written as 7 to the power 0, and so that's equal to 1. And you might think, oh, what's the point of all that? Well, in more advanced maths, it's something that we rely on quite a lot. We use indices a lot for something called calculus, which is probably one of the best things ever discovered. And so we need to know all the rules of indices and what they are. So this is one very special one. Okay, so that's that one. 7 to the minus 1. This is using the idea of the reverse. So we get the reverse of 7 here, we get the reciprocal, so it's 1/7. Again, this is due to division, so these are the 3 types of division here: more than 1, equal to 1, less than 1. And the division here would be, well, there must have been more than on the bottom than on the top, so it might have started off with, say, 7 cubed. It was divided by something that was 1 larger, 7 to 4, 1/7 larger, and that gives us an extra 7 on the bottom as a result, because only the first 3 will cancel, leaving us 1 extra on the bottom. If we do 3 minus 4, division is subtraction, we get 7 to the minus 1. But as we can see, it must be equal to a 7th, because there's an extra 1 on the bottom. So the negative number, it gives reciprocal of it. Up here we looked at brackets, and of course we said before that brackets mean multiply. So 2 3 is 6, and 7 to the 6. And that's because we're cubing what's in the bracket, which is 7 squared. 7 squared times itself 3 times is 7 squared times 7 squared times 7 squared. 2 plus 2 plus 2 is 6. 3 2s is 6. 25 to the half, another example of the reverse. So here we're going to reverse the concept of squaring and generate a square root. And to do that we're going to use the reciprocal of 2, which makes sense because 2 squares, the reciprocal of 2, will do the reverse, wouldn't it? So square root of 25 is 5. Instead of squaring, it's square roots.